Hello dear students, today we are going to discuss one of the most important chapters for the JEE preparation, which is actually treated as a base or foundation for the entire physical chemistry learning, and the chapter is Stoichiometry. Today I am going to discuss certain tricky and important problems related to the stoichiometry, which has two parts, namely gravimetry and volumetry. Now my dear students, looking at the first question which is being sliding, that we have a solution containing 2.68 into 10 to the power minus 3 mole of an ion AN plus, which requires 1.61 into 10 to the power minus 3 mole of permanganate ion for the oxidation of this N plus 2 AO3 minus in acidic medium. Then the question is to find the value of N, that is nothing but the oxidation state of A in the starting compound. So when we encounter such problems which are related to volumetry or the stoichiometric calculations, including equivalent concept, we have to first understand that there is a reaction which is taking place between the concerned oxidizing agent. I am calling this as oxidizing agent because you can see during this reaction the oxidation state of manganese, which is plus 7, and we all know that under acidic condition manganese will change into plus 2. I mean to say, if you have taken HCl as the medium, the product will be MnCl2. If it is H2SO4, it will be MnS4, etc. And since this is undergoing the reduction, we call it as oxidant, and therefore this is reductant or reducing agent, where the oxidation state is clearly mentioned in the problem is changing into this AO3 minus, where the oxidation state is being projected as plus 5. So if you see in this particular problem, there are two components that are reacting. It's a volumetry related problem, and you have been given the number of moles of this particular substance as 2.68 into 10 to the power minus 3 and the 1.61 into 10 to the power minus 3 moles of permanganate are reacting with each other. These are the mole of the two compounds that are being mentioned. So in such problems, since there is a lot of complexity involved, we are not sure about the oxidation states, we are not sure about the element, it is always better to go for equivalent concept. I mean to say, here as per law of chemical equivalence, we write the gram equivalence of the oxidizing agent would be equal to the gram equivalence of reducing agent, right? So this is what we have learnt in stoichiometry, that to in equivalent concept or law of chemical equivalence, which clearly suggests that the gram equivalence of the two substances reacting completely will always be equal. Hence I am equating the equivalence of these two substances. Therefore when you elaborate, you will find that the number of moles of this AN plus, which are being given as 2.68 into 10 to the power minus 3, has to be multiplied by the change in oxidation state, which is generally regarded as the what you call N factor. What I mean to say, that the N factor, the change in oxidation state, the change in oxidation state of this compound, if you see, it is undergoing the reduction, hence the N factor or change in oxidation state per mole of A has to be taken as 5 minus N, that is upper oxidation state minus lower. I am saying this because this is undergoing oxidation, my dear students. And here in case of this permanganate ion, you will see that the change in oxidation state of manganese is being 7 minus 2, which is called as N factor. So when I am multiplying the number of moles with the N factor of this A plus N is 5 minus N, and the N factor when is being multiplied with the moles of this permanganate, you will be getting what you call the equivalence of permanganate. And this is a simple equation what you have got, which is containing only one unknown, nothing but N. So therefore when you simplify this, and you will get the oxidation state of A to be plus 2. I mean to say, in this reaction the oxidation state of this A is changing plus 2 to plus 5. So in this problem we have just used the equivalent concept. In the second question, the percentage of copper in cupric salt is asked, and the information provided is 6 gram of the salt was dissolved in water and made up to 250 ml, and 25 ml of this solution after the addition of excess of potassium iodide required 22.3 ml 0.1 normal hypo solution to react with the liberated iodine. Our purpose is to find the percentage of copper in cupric salt. I mean to say that in this particular problem you have been given that it is the salt is cupric, that is the oxidation state of copper in that particular compound is +2. Now when this 6 gram of the salt, whatever you have taken, is dissolved in water and made it to 250 ml by adding H2O, you diluted the solution to 250 ml. From that 250 ml you picked up only 25 ml for the concerned reaction. I mean to say the 25 ml of this solution was, which is obviously comprising the copper +2, is made to react with the aqueous solution of Ki, and we know that copper +2 is a good oxidizing agent because copper +2 is stable in +1 oxidation state, as we know that it is the pseudo noble gas configuration in +1 oxidation state. So copper is changing its oxidation state from +2 to +1, and in this process this is going to oxidize the iodine, and whichever iodine which is liberated is being titrated with the sodium thiosulfate, and the information regarding the sodium thiosulfate is provided to us. We have taken 0.1 normal sodium thiosulfate, and the volume of sodium thiosulfate which is required for the complete neutralization is being mentioned as 22.3 ml. Now using this data we have to find out the percentage, I mean to say the weight percentage of copper in the given salt. I mean to say that in this particular problem, if we start with the gram equivalents of hypo, because this is the information that had been provided to you, gram equivalents of hypo we get by multiplying the normality with the volume of the solution in liter, because we know, my dear student, that normality is equal to gram equivalents divided by volume in liter. I mean to say, if you have this particular compound, the gram equivalents of hypo, I am writing it as E of Na2H2O3. The normality of hypo is mentioned as 0.1. Volume of hypo solution in liter will be 22.3. In liter it is divided by 1000. So these are the gram equivalents of hypo which are being used. They are used against to the iodine, and in that particular reaction, you know, when hypo reacts with iodine, this is reducing agent and this is oxidizing agent, hence the gram equivalents of these two are equal. Please note, my dear students, the gram equivalents of the acid are always equal to the base, and the gram equivalents of the oxidizing agent are equal to that of reducing agent. So here I am saying that the gram equivalents of hypo are equal to the gram equivalents of iodine, and you see from where this iodine is obtained. Obviously it is obtained from Ki by the reaction with Cu+2. So you would extend this saying that the gram equivalents of all iodine whatever I have obtained from the Ki, and Ki has been oxidized by the copper ion, because here in this particular reaction this is oxidant and this is reducing agent, hence the gram equivalents of these two are equal. You see how beautifully we have crafted this. We have taken the equivalents of hypo and we have equated that to the iodine, and then from there we have arrived at the Ki, and there we are ending at a copper ion. I mean to say the link is properly established so that the information which is provided to you is regarding the hypo has to be converted in the form of copper +2, because the question asked is about the copper +2. Hence finally you would say that the number of gram equivalents of copper +2, when you write 22.3 into 10 power minus 3. But please notice, my dear student, that these are the equivalent that are present in 25 ml of the solution, because the reaction that you had done initially is for 25, and when you are calculating the gram equivalents for 250, obviously you have to multiply this with 10 where your 0.1 vanishes. I am repeating, this is the gram equivalents of this particular compound. You can see here this is turning out to be 22.3 into 10 to the power minus 4. So 22.3 into 10 to the power minus 4, the gram equivalents of Cu+2 that are present in 25 ml, and when I am converting that into 250 ml, I am just multiplying that with 10. The multiplication factor is 10 because you can see here from here to here we are moving where there is difference of 10 times. So here these are the gram equivalents of Cu plus 2. When you write that gram equivalents, you will write that as the weight of Cu plus 2 divided by equivalent weight of Cu plus 2. I mean to say the gram atomic weight divided by the n factor of Cu plus 2. You can see here clearly the change in oxidation state is nothing but the n factor in this case. Change in oxidation state of copper is only 1. So therefore, when you simplify this equation finally, you are going to get the weight of Cu plus 2. Percentage of Cu plus 2, that is weight percentage of Cu plus 2 is weight of Cu plus 2 here, my dear students, 63.5 into 22.3 by 1000 divided by the initial weight of the salt is given as 6 grams, and when you multiply this with 100, you are going to get your answer as 22.3 percentage or approximately 23.6 percentage more precisely. This question we have started discussing from the hypo and we moved on to the copper ion. In the third problem, we have taken 200 grams of marble chips which are dropped into 1 kg of solution of hydrochloric acid which is containing only 1/10 of its weight as pure. And you have been asked to find the how much of the chips will remain undissolved, that the weight of CaCO3 remaining undissolved, and what is the weight of anhydrous CaCl2, that is the product which is obtained, and carbon dioxide gas also. So in this problem you should understand that when you have taken the marble chips is nothing but calcium carbonate, and when it is made to dissolve in a mineral acid, you know that you are going to get the salt and water. Since they are carbonate, they are going to also evolve CO2 gas. So here this is the concerned reaction which is taking place to produce anhydrous CaCl2 and CO2 along with water. And once if the equation is given, you can see that the information is regarding the weights. Hence it is always better to use mole concept to solve such problems. In the previous two questions I have discussed by using the equivalent concepts. Now you go by mole concept, which will be very, very simple, and there is no hard and fast rule to use any of these two concepts, that is mole and equivalent, or for a particular stoichiometry. I mean to say, it is not mandatory that you should use only mole concept to gravimetry and equivalent concept to volumetry. Any concept you can use to any of these two metries, right? So here in this particular problem you have been given the weights as 200 and the weight of HCl is mentioned as 1 kg, but of which only 1/10 is pure or usable. I mean to say that you will be using only 100 grams of HCl in this. And before I go further to convert this weight into the moles, I may have to balance this equation. You can see here by placing 2 over there, the entire equation gets balanced. And since this 1:2 or 1:1 indicate the mole ratio but not mass ratio. Remember my students, stoichiometric coefficient does not indicate the mass ratio. Hence I can't say for every 1 gram 2 grams is reacting. Rather we should say for every 1 mole 2 moles are reacting. Never dare to say for every 200 grams 400 grams will react. It's not possible because you can see you have taken only 100 grams. So when you have taken only 100 grams, how can you anticipate 400 grams to react with it, right? So therefore this indicate only the mole ratio but not mass ratio. Hence immediately it has to be converted into the gram moles. The gram moles are obtained by dividing the weight of the substance with the molecular weight. The molecular weight is 40, 12 and 48. Put together is 100. And the molecular weight of HCl is 1 plus 35.5, that is 36.5. This is the moles with which you have started the reactions. Now you need to predict which reactant will be completely consumed during the course of reaction. Which reactant is completely consumed during the course of reaction if this reaction goes to 100% completion, known as limiting reagent. What I mean to say, that out of these two you may have to predict which one will be completely over, and whichever reactant is completely over is actually called as limiting reagent. For that, there is a specific method to determine which one is a limiting reagent. And don't ever think that whichever you have taken low might be the limiting reagent. At times it may be possible, but not in general. Then in such cases, what you have to do is you have to assume. Let's assume in case 1, I'll assume CaCO3 as limiting reagent. I am saying limiting reagent, the reagent that is completely consumed during the course of reaction. Suppose if it is CaCO3, for every 1 mole I can see here 2 moles of HCl has reacted. For every 1 mole of this, 2 moles of HCl has reacted. And how many mole I have taken here, my dear students? 2, right? This division will give you the value 2. For every 1, if 2 moles have reacted, for every 2, how much will react? Obviously 4. So 4 mole of HCl is what we anticipate reacted. And how many you have taken indeed? You have taken initially 100 by 36.5. So for 100 by 36.5, can you expect 4 mole to react? For 100 by 36.5, whose value is less than 4, can we expect this to take place? Obviously not. That means we made a mistake here by assuming this as the limiting reagent. So let's move on. I'm going to say let's predict the other one whether it is acting as a limiting reagent or not. Now in such case, I'll assume HCl as limiting reagent. I'm writing here completely, you call it as limiting reagent, the reactant which is completely consumed. Suppose if this completely gets consumed, you can see here for every 2 mole, 1 mole has reacted. For every 2 mole, 1 mole has reacted. For every 100 by 36.5 mole of your HCl, how much you can anticipate? 2:1 is the ratio, 2:1 is the betting. For every 100 by 36.5, I will be treating this with 50 by 36.5 mole of this particular substance. 2:1, 100 by 36.5, 50 by 36.5. So how much is supposed to remain? This seems to be the genuine, right? This is a genuine one because you can see this value is obviously less than 2. So what I mean to say that assuming HCl is a valid one, whereas assuming CaCO3 as the limiting reagent is not valid. So this is your limiting reagent and this is going to remain known as excess reagent. So of this reaction you have seen that HCl acting as a limiting reagent. So these are the number of moles of CaCO3 remaining. So when it comes to the product, you have been asked to find out how much of marble chip is remaining. You can see here that the weight of CaCO3 remaining, I have to multiply the number of moles with the molecular weight of CaCO3 to get the weight of CaCO3 remaining, which is turning out to be 63.01 gram. And now when it comes to the calculation regarding the products, I mean to say the weight of CaCl2 has to be obtained. So since this has sacrificed, I mean to say since this has reacted completely, now it is going to predict how much of CaCl2 will be produced. For every 2 mole you can see 1 mole is produced, 2:1 is the betting. For every 100 by 36.5 I can expect 50 by 36 point, that is exactly half mole of CaCl to be produced. And same is the case with CO2 also. For every 2, 1 is produced. For every 100 by 36.5, 50 by 36.5 are the mole of CO2 formed. So here in order to find the weight of CaCl2, I have to multiply the number of mole of CaCl2 with the molecular weight, and to get the weight of CO2 I have to multiply it moles with the molecular weight of CO2, that is nothing but 44. So after your simplification or calculation you will get somewhere around 152.06 gram of this and 60.27 gram of CO2 as your final products. So you can see, since you have entered into the laboratory by taking 200 grams and 100 grams of these two, you will be ending up with finally obtaining 63.01 gram of what you call the remaining CaCO3, 152.06 gram of remaining CaCl2 and 60.27 gram of remaining or formed what you call the products. So this way we are going to find out each and every component that is involved in a chemical reaction. 50 gram of caustic soda that is NaOH, will be completely converted into sodium chlorate and sodium chloride by the action of Cl2. What weight of MnO2 and HCl, what volume of HCl, which is containing 300 grams per liter, were used to form the necessary amount of Cl2. I mean to say, here there are two reactions that are involved in this particular problem. You can see here that NaOH, caustic soda, is reacting with the chlorine gas to give you NaCl, NaClO3 and water. You know that this is base and this is acid, my dear students. Please notice that this is an acid base reaction but not redox. This is acid base, hence it has become the redox. It's a disproportionation reaction where you can see the oxidation states of chlorine are changing into -1 and +5. That is the same element is undergoing both reduction as well as oxidation. But it's an acid base reaction as well as redox reaction. So here in this particular reaction, you try to balance this reaction, you will see that you may require totally 3 moles of Cl2 for every 6 moles of NaOH, where 5 moles of this thing and 3 moles of water is formed. So I am going to use the mole concept, hence I am balancing this equation. Because I had been given the weights, I thought it will be easy for me to balance this and solve it by using the mole concept. And you have been asked to find out the amount of Cl2 which is actually obtained by virtue of a reaction between the manganese dioxide and HCl. So when MnO2 reacts with HCl, you know that Cl2 is obtained along with MnCl2 and water. So when you balance these equations, you will see that we will be writing around 4 moles and I think the entire equation is balanced. Now you see what information is provided to you. In this problem you had been given that the weight of NaOH reacting is 50 gram. What I mean to say that you had been given the weights, immediately convert that into moles by dividing with the molecular weight. Molecular weight of NaOH is 23, 16 and 1, that is 40. The number of mole of NaOH reacted or given is 5/4. Since you had been asked about the MnO2 and HCl, you have to link up these two, and this way it is possible. I am going to say from number of moles of Cl2 you can obtain the number of moles of these two as well, which are asked. So here what I will do is I will find out the number of moles of Cl2 by using the stoichiometric coefficients. I am going to say 6:3. In what ratio they are lying? Actually 2:1 or 1:1/2. For every 1 mole of NaOH, if you effort to get 1/2 mole of Cl2, for every 5/4 I can expect half of it, that is 5/8 mole of Cl2 to react. 6:3 is the ratio, is the betting. For every 5/4 I will be getting 5/8 as the number of moles of Cl2. So these are the number of mole of Cl2 which have reacted in the second reaction, which are produced from the first reaction. So you can see here, for every 1 mole, 4 mole of HCl is involved. For every 1 mole of Cl2 production, 4 mole of HCl is involved. For every 5/8 I can expect 4 into 5/8, that is 5/2 mole of HCl2 involved. It's very simple, my dear students. Check out once again. For every 1 mole, 4 mole of HCl is involved. You know the number of moles of Cl2 from here. The number of mole of Cl2 here is 5/8. If I would have taken 1, I would have got 4 mole. I have taken 5/8, hence I am getting 4 times of 5/8 is nothing but 5/2. And you can see one more thing, for every 1 mole of Cl2, 1 mole of MnO2 is involved. For every 5/8, the same would be involved if it is MnO2. Now you see you have got certain information regarding this, right? You got the number of mole of HCl as well as MnO2. Now you check into your question. Now you can see there the weight of MnO2 is asked. It's very simple enough. Since number of moles of MnO2 that are to be taken to produce 5/8 moles of Cl2 are 5/8, you can see. Then now the weight has to be divided with the molecular weight. Weight of MnO2 will turn out to be 5/8 into 87, right? So this is 1 question which is asked to you, and the answer for this problem is 54.38 gram. And moving on further, you had also been asked to find the volume of HCl which is containing 300 grams per liter. First, what I will do is I will find out the weight of HCl from this, because you know number of moles is weight by molecular weight. If I multiply the number of moles with molecular weight, I will be getting the weight of HCl. So this many grams. Now as per the information which is given, 300 grams of HCl is present in 1 liter of solution. Therefore, if I take 5 by 2 into 36.5 gram of HCl, it would constitute how much volume? What I mean to say, that when you simplify this, the volume of HCl is turning out to be 5 by 2 into 36.5 divided by 300 liter, which is turning out to be 304.17 milliliter. You can see it's as simple as that. You have been given the information regarding the NaOH, where you can see 50 grams is reacting, that is 5 by 4 mole are reacting. For every 5 by 4 mole, you got 5 by 8 mole, because the ratio is 2:1, half, 1:half, hence 5 by 4 has given 5 by 8. This 5 by 8 has given the equal amount of MnO2 when you have balanced this equation. You can see 1:1 is the mole ratio. So 5 by 8 and I got 5 by 8, and when I multiplied that with the molecular weight of MnO2, I got the weight of MnO2 that need to be taken. And from this ratio you can see 1 is reacting for 4 moles of HCl. For every 5 by 8 I will be using 5 by 2 mole of HCl, and 5 by 2 mole in the sense this many grams. Had been given that for 300 grams of HCl, 1 liter of solution we have, for this many grams how much of volume would I be having. Question number 4, and the answer is, so these are the entire data that has been asked in this problem.